Okay, don't go anywhere just yet. I want to welcome you back to the second edition, or this bonus edition, to building a racing Powerglide. Now recently I've been getting some emails from customers saying, well, the car I'm running has a little bit more horsepower, or I'm running a little bit more body weight than the theoretical car that you're building this transmission for. So I'd like to know, what's the next upgrade? What is the next step up I should do to put more durability into the Powerglide if I'm running a little bit more horsepower? Well, the same holds true to Robert and Pat Warren, that this transmission is really for. That's going to be a spare transmission for them. Now, both of their cars are running in the 5.5 second range, 1/8 mile. In some cases, it's running quicker than that. So they're certainly in that higher than 700 horsepower, maybe closer to 800 horsepower range. And what they have found is that building the transmission, just like we did here, is fine, but maybe once a year or so, they would wind up breaking one of the 176 planetaries. So what Robert's been doing, he's either bought a new aftermarket gear set, or has rebuilt a 176 and installed the straight cut 180 racing gears. And as of this taping, so far, him and Pat have not broken one of the 180 racing gear sets. So I would say that's definitely the next upgrade. We'll do that for this transmission. You also see I've already removed the pan. I've taken the store-bought valve body out. I'll later disassemble this transmission, re-drill the back of the case, so this will accommodate a Pro Tree, or a double dump Pro Tree trans brake valve body. And we talked about that earlier in the video. We will go ahead and do that with this one. Also, I want to build my own racing trans brake valve body. What we'll do, we'll take the donor valve body that was originally in this transmission, and by using a kit, we'll modify it and change it over to a trans brake valve body. Now, if you've watched any of my other videos, you know I don't get brand specific. I talk in more general terms when it comes to parts. However, in this case, to my knowledge, there's only one kit available out there to take a stock valve body and change it to a trans brake valve body. And that's sold by TSR, which is a racing company that's in New Hampshire. And the fellow that runs it, his name is Carl Monroe. And you may know that name because Carl Monroe wrote one of the definitive books on building a racing Powerglide. When he found out I was making this video, he was interested in that, and he wound up actually sending me some parts to use in this second half of the video. And so I'll do that. And he also helped me out with a few pointers, so I'm certainly appreciative of that. So let's go ahead and start with rebuilding one of the planetaries. Okay, we'll go over to this side of the table, and I have a 176 gear that Robert broke, I don't know, a couple years ago. I've already removed one of the gears. Here it is. You can definitely see the tooth damage here. In fact, every one of the gears have at least one tooth knocked off of it. The ring gear also has some damage. And I've already ground down the tops of these gear pins. And I have one more to grind. You can use a cut-off wheel, a die grinder. The best thing, though, is to use an angle electric grinder that has an abrasive wheel on it. And what you want to do is you want to take all of this stamping off. These are kind of riveted into place. So you want to ground those down flush with the back part of this output shaft hub, I guess you would call it. And you're going to touch a little bit of that area. You're going to shine it up, but you want to try to keep that to a minimum. You just only want to cut that down flush. So we'll do that one real quick. Okay, I'll put my safety glasses on. I'm also going to take this 1 1/4 galvanized pipe, put it on the output shaft, just like that. That'll protect the machined part of the shaft. So sometimes when you're using the grinder, you can accidentally kind of go up there and you might put some burrs on there. So that kind of protects that. I've already got the abrasive wheel on my grinder, and what we want to do is to take that stamping away, but try not to take too much of the material off of the hub. Let's go ahead and do it. Okay, 1 1/4 galvanized pipe, put it on the output shaft, just like that. That'll protect the machined part of the shaft. So sometimes when you're using the grinder, you can accidentally kind of go up there and you might put some burrs on there. So that kind of protects that. I've already got the abrasive wheel on my grinder, and what we want to do is to take that stamping away, but try not to take too much of the material off of the hub. Let's go ahead and do it. Okay, that looks pretty good. Now we want to go ahead and hammer these pins out. The way I do it is I put the planet on a couple blocks of wood and then stick it down in a something like a drain pan, because when you knock these out, there's some, you know, little needle bearings that'll fall out and you don't want them flying all over the shop. Okay, I'll take my 5/16 drift punch and knock these pins out. What I want to do is remove the short gears first. Once I take the short gears out, I can remove that sun gear and the washer behind it. Now this is an interference fit, so therefore you're going to have to hammer it all the way out. It's going to be tight all the way out. And understand that, you know, these pins may have little burrs on it which can damage the needle bearings in there. Also, no matter how careful you are, you may slip and, you know, your punch may wind up damaging one of the needles too. So once you get all of these needles, and there's little spacers too, check them for damage. If there's any question about it, these spacers and needle bearings are available and you would want to replace them. There we go. Take the gear out, and you know, the little needles might fall out just like that. That's fine. Let's take the other short one out. All right. Now when I take this gear out, then the sun gear will fall out from underneath. So I'll put my hand under here. And there we go. There's the sun gear and the washer in behind it. Now along with the needle bearings and those spacers, you'll see a couple of these thrust washers here that have the little tang on it. There's 3 of those. They go underneath these short gears. There's also some more thrust washers, but they are tied to these long gears, so they have to come out first. Okay, now let's get the long gears out. Okay, we got a mess here now. Okay, you see what we have here. We've got these long gears and, you know, of course the little needle bearings and spacers that were in those. You have these thrust washers that have a kind of a figure 8 look to them. And just go ahead and get the rest of this stuff out. There's also some more of these thrust washers that are on the long side of those long gears. And now we want to take all of these pieces out and clean this planet up real good and get it ready for rebuilding. You have 3 of the figure 8 type thrust washers. You have 6 of the thrust washers that have the little tangs on them. Of course, you have the thrust washer that goes behind the sun gear. You have 3 of these wide spacers, and you have 12 of the shorter spacers, and a whole bunch of needle bearings. Understand the 3 shorter gears use 20 needle bearings apiece, and the long gears use 40 needle bearings in 2 rows. And of course, there's 6 of the pins that we drove out. Now the only thing that I want to check on the planet is on the inside. I want to look down inside the planet carrier and take a look at this bushing. This is the bushing that the input shaft, the end of the input shaft rides on. I've looked at this one and it's in good condition. But if you needed to replace it, they are replaceable. I want to show you how to do that. So I've got an old 182 gear set that I've taken the gears out of it, and I've put it over here on my portable bench, and I'll show you how to remove that bushing. Okay, I've taken the planetary and output shaft and clamped it in this bench. I take a 1/4 inch pipe thread tap and run it down in here and tap out the bushing. Actually, I've already done it. I just ran it down until it bottomed out. Then I have this 1/4 inch nipple, it's 2 inches long, put a T on it, and I'll thread that right down into the bushing. Just like that. Now, if you happen to have a slide hammer that has one of these 2-jaw little pullers on it, you can see you could probably put the puller, you know, right in there and then just slide hammer it out. If you didn't have this, but you did have an assortment of these, you know, ladies' foot pry bars, we should be able to remove this bushing. Let's see if we can. I've got this one and you know, 2 different sizes. This smaller one really is not what I want. I really need 2 of this larger size. But let me see if we can get it out. We'll just put one in one side of the T fitting and the other one in the other, and then just spread the pry bars out. There you go. Get a little different bite on it. There we go. There you go, and there's the bushing. Now what you would do is you'd take your new bushing and just put it on the end of your input shaft and then put it right down in there and drive it home. I think if you just use a brass hammer, you wouldn't damage your input shaft, or you could also use your shop press if you have one. Now when you reassemble these planets, you can reuse the old pins. You just simply you know, press them back into place or hammer them back into position, and the part where you ground down, you could simply put 2 tack welds there. I don't like that. I would rather use the aftermarket pins. I'll show you those right now. All right, here's one of the aftermarket pins. On one side you have this shoulder, and there's also a little roll pin pressed in through one corner of it. On the other side you have a screw with a washer, and what you would do, you would insert this pin just like the original, and the little roll pin here needs to line up with the groove that's in the bottom of the planet carrier right here. Then on the other side you put the screw and the washer down into the pin like that. And what you will do, you need to torque it down, but usually you just go a little bit snug, because if you torque it too much, you'll actually crush the carrier slightly, and it may interfere with the gear turning correctly. So you might want to do a dry run. You give it a nice firm turn, make sure that the gear turns okay, take it back out, put a drop of red Loctite on it, and then run it down snug permanently, and then install the rest of them the same way. Now earlier in the day, I took this aftermarket pin and I drove it down through one of these holes, and I discovered there's a slight interference right in the area where this shoulder meets the carrier face. I found that the diameter of the shoulder on this pin was a little bit too large, and it interfered with this raised portion of the carrier housing. So what I did, I cut a little bit of that edge off. Here it is, right there. Took that little bit of material off. Now it lays down in there and it misses that raised portion. So check the one that you're working on. You may have to make a modification the same way as I did. Now, it just so happens that Robert had another planetary that he broke a couple years ago, but this is a rebuilt aftermarket unit. It has a special output shaft made for racing only. It only has the single lube hole. It doesn't have the extra holes for the governor and for the, you know, speedometer drive. So this is a race only unit. It's also welded to the carrier back here, much stronger. Of course, because the gears were broken, there's some superficial wounds on the carrier, but there really isn't any damage. Now this one also has removable pins, but it uses this retainer to hold the pins instead of screws. So this is the unit we'll put the 180 racing gears in. Okay, on the table here you see I have the aftermarket gears. You have the 3 long gears, the 3 short gears, the 2 sun gears, and the ring gear. And I also have the aftermarket pins that go into the aftermarket case that we're going to rebuild. First thing we want to do is install the needle bearings into the gears. All right, let's start with the long gears first. Remember, there are 2 rows of needle bearings, and they're separated by one of the wide spacers. There's 3 of these wide spacers. Now I like to set that spacer in the middle, so I'm going to create a little standoff by using this little 10mm socket. Put the spacer on top of it like that, then put the gear on top of the spacer. Now that when I put the needles in, they won't go all the way to the bottom. To make the needles stay in place, you need to put a little bit of wheel bearing grease or some assembly lube. You can use petroleum jelly. I think you'll find that petroleum jelly isn't quite viscous enough, so I'm going to use a little bit of wheel bearing grease, and then I need to put 20 of those needles in. Alright, and when you put the last needle in, you'll have to kind of wedge it in there. It'll be kind of a tight fit. There we go. Then we top it off with, one of the little thin spacers, just like that. Put a little bit more grease on it, kind of glue it in there. Then I'll carefully flip it upside down, remove the socket, glue this side up with some grease, and put 20 rollers on this side. Put the last one in. Take one of the short spacers, put on the top, put a little bit more lube on it, kind of grease it down, kind of glue it up. Set that aside and do the other 2 the same way. All right, here's a little trick for you. Once you get that first row of needle bearings in position, take your gear pin, drop it down in there, and now you have a mandrel to kind of support the second set of needles. I find that the needles go in there a little bit easier. Of course, they can't fall down through the other side, and in which case you'd have to fish them back out. It also looks like the needles stay upright a little better, and it's certainly something you might want to give that a try. Okay, now let's do the short gears. You already know what to do. We put a short spacer in, 20 of the needle bearings, and another short spacer on top of that. There you go. Do the other 2 the same way. Over here at my portable table, I have the planet carrier and output shaft, and what we want to do is install the long gears first. To do that though, I need to install a couple thrust washers. Remember the little thrust washers that have the little tang? Well, that needs to go on the bottom. Okay, and that little tang is going to fit in a hole that's on the floor of the carrier. So I'll put a little bit of grease on the thrust washer and glue it into position. Now the figure 8 type thrust washer fits on the top, on the bottom side. Just remember there's little slots on one side. The slots always face the gear. And understand it'll fit right under here just like that. And there'll be 3 of them, of course. You have one in this position, one in this position, and one in this position. I'll take a little bit of grease, put on the back, and glue that to the top. And if it falls down, that's all right. I'll just have to reposition it Okay, now I'll carefully take the long gear and slide it into position. Then I'll take my little finger and make sure my thrust washer on top is lined up. Then I'll use a little tool that I've made. This is a 4-inch long, 1/4-inch pipe nipple. I've cut the threads off of one side. It's a little bit smaller than the gear pin, so it makes a real good alignment tool. Drop it down through there, reach underneath, make sure my thrust washer on the bottom is lined up, and then have the tool go all the way through. Now I know that the gear is pretty well lined up. Now it's time to actually put the gear pin in position. Okay, this particular style of gear pin has a little slot made in it. That's for that little retainer, and it'll need to be lined up. So as I install it in the Planet Carrier, I'll show you that. Okay, the pin should go down easily until it gets near the bottom. That's where the interference fit is, down here. And remember I said the slot needs to line up so you can put that retainer in place. So I have this old hacksaw blade that's broken, and I put that in the slot, and then I can kind of rotate that pin and use the hacksaw blade as an alignment tool to make sure that the slot is pointing toward the center of the planetary. So in other words, when I put the pin in this position, the slot will be facing that way, and the hacksaw blade will be like that. When it's in this position, the hacksaw blade would be like this, like so. All right, now I want to tap that pin down a little bit with, say, a brass hammer. You could also put this in your shop ram. But what I want to do is I don't want to bring that slot down flush with the back of this carrier. I want to be shy maybe a 32nd of an inch. Otherwise, it'll be very difficult to try to get that retainer in place later on. So let me tap it down with my little brass hammer here and kind of keep an eye on it. And I think that's as far as I want to go. Now I'll put the other two long gears in place. Okay, right about now you may have discovered something, and that is those little figure 8 thrust washers. They need to go between the holes that are closer together. If you look at the distance between these holes, you'll see two of them, a pair is kind of closer together. The next two are a little bit further apart. If you have the thrust washers in the wrong pair, you'll find that the hole doesn't line up. So I've looked down in here and I do have them in the correct position. Now I'll go ahead and put the gear pins in position, making sure that the slot is lined up toward the center of the carrier. Okay, now we want to put the short gears in, but remember, before we put the short gears in, I have to put that sun gear, that input sun gear, because you remember earlier, those short gears actually capture the sun gear in position. Now on regular 176 gears, there's no top and bottom to the gear or the sun gear. However, with these aftermarket straight cut gears, the input sun gear does have a top and a bottom. The smooth side will go down against that thrust washer, and this countersunk side will face up, and that's where that Torrington bearing will go. This countersunk area is there because these gears are slightly wider than the 176 gears. So let me put the little thrust washer in place. I'll put a little bit of grease on it. We'll lube all of this up with transmission fluid once it's all together. All right, then I'll take the input sun gear, remember smooth side down, and I'll kind of thread it between those long gears. Okay, and now I'll start putting the short gears in. Now there's those same thrust washers that have the little tangs on them, but in this case there's no hole. You just simply have the tangs toward the center of the carrier. And put it in here like that. And then slide one of my gears in position. kind of line that thrust washer up. I'll use my little tool and I'll look down in there and see what I got. Take a screwdriver and kind of line it up a little bit, and then tool goes right down in there. I'll put the other two in. Okay, now I'll take the lock retainer and put it in position, line up the 3 screw holes. Might use a small Phillips or a scratch-all. Then take the 3 screws and put them in there, just about 2 or 3 threads for now. Okay, now I want to carefully tap each one of these pins down so the retainer is flush with the back of the planet body. Now I'll remove each one of these little screws, put 1 drop of red thread lock on them, and then torque them down. Okay, drop the Torrington bearing in position, squirt some transmission fluid on it, and it's ready to go. Okay, welcome back to this last part of the second edition of building a racing Powerglide. In this chapter, we are going to build our own trans brake valve body using an available kit. What we'll do is we'll take the original valve body that was in our project transmission, disassemble it, make the modifications needed, and put it back into the transmission. Now, normally this kit involves the use of a milling machine. And if you're like me and you don't have a few $1,000s to spend on a milling machine, I believe if you're willing to spend a couple $100s in some tools and willing to fabricate at least 1 tool, you should be able to duplicate this kit without any problem. Let's first take a look at the table and see some of the tools that we'll need. Okay, you'll definitely need some safety glasses because you are working with power tools, you're cutting metal, so you definitely need some eye protection. I have a little paint marker here that will be used. You need some, end wrenches and some sockets, of course. A small pair of long needle nose pliers and some side cutters. A couple large flat files. Hopefully you have one that's real coarse and one that's kind of medium. You'll need some red Loctite and some epoxy. You need a couple taps, 1 1/4-inch pipe tap and the other one 10 by 32. Couple Allen head wrenches or sockets, 1/4-inch, and I think the smaller one is 3/32. A small punch, I think 1/8 inch, pocket magnet if you have it, an assortment of those pick tools. That's good to take your valves out of the valve body with. A small screwdriver. Hopefully you even have old beat up broken screwdriver. That'll be used in a couple places. I have an 1-inch torque wrench, good to have if you happen to have it. Brass hammer, or at least a small ball peen hammer. A veneer caliper, and hopefully you have a small steel ruler. Now when it comes to the power tools, you will need one of these small base routers. Now there are several of them on the market. I happen to like this one because I like the square base and I like the height adjustment. You can make a quick adjustment, and it also has a provision for a fine adjustment with a little thumb wheel here. As an optional tool, one of these small die grinders that have the 1/8 inch chuck. They're real good to use if you put a small stone in it, and they can kind of deburr your work after you've done the router work. You may have some little ragged edges, and those little stones can be used to kind of clean that up. Now when it comes to the stones and the bits that we will use, let's take a look right here. Okay, we have this 3/4-inch tapered or countersinking bit. You saw me use it earlier in the video, chamfering out a hole in the case. You have this tapered stone. I have one of these very small stones that's used on the small die grinder, and I have 3 carbide burrs. One has a 1/4 inch ball on the end, the other one is a 1/4 inch with a little dome on the end, and this 1/4 inch one has a flat top on it. Now actually only 2 of these are absolutely needed, and that is the countersinking bit and the 1/4 inch carbide burr that has the little dome on the end. The other ones are nice to have, good optional pieces. Okay, now let's take a look at what's actually in the kit that we will use in this project. You have the separator plate, and by the way, this kit does not use any gaskets. You have the electric solenoid, you have 2 springs, you have this valve. This is actually the trans brake valve, a short 1/4 inch aluminum pin, a couple threaded plugs, and you have this plate that goes between the case and the governor support. And you also have, like in my case, a well-worn instruction manual. All right, now let me show you the last tool that you will use. This is something that I fabricated. It is my valve body holding fixture. What it's made of, it's an 1/8 inch aluminum plate. I have it mounted on 2 standoffs here. These standoffs really need to be 2 inches thick. Now they're 2 pieces of wood and they're 1.5 inches, but if you're going to make your own, you want to have these standoffs about 2 inches thick. And what I do is the 2 halves of the valve body, I just simply bolt it to the back. I have some holes drilled so I have a couple screws, 3 screws to hold the valve body in position. I calculated where all of the cuts need to be made on the 2 halves of the valve body, and then made sure that I had a window large enough so the router bit can go down through it, but yet the hole is not too big that you don't get a full support of the base of the router. I've also made this little fence here. I found that by moving this fence in a certain position, you have a nice straight edge for the router to rest against, and then it's easier to make some of these real small straight cuts. Okay, now let's go ahead and take this valve body apart. I'll first take the manual valve out, and of course the modulator valve has already been removed. And now I need to take the 15 bolts off that hold the 2 halves together. Now of course this valve body has been into before and it'll be clean. The one you're working on will likely be all oily and sludged up, and you may have some trouble with some of the valves being stuck. So let's go ahead and get this apart. And we have the 2 halves, we have the separator plate, and 2 gaskets. Now let's start taking some of the valves out of the 2 halves of the valve body. Okay, we'll first flip the upper valve body over, and we'll remove this top plate here. The heads on these bolts are 7/16. And we take the plate off, and there's also a gasket under it too. Lay that aside. Now we want to take the kick down and throttle valve assembly out of the valve body, and to do that we need to remove that rivet. Sometimes you have to get under it with a cold chisel to loosen it, and then take some side cutters and pull it out. And go ahead and pull the valve out. You'll see has this part, and there's some more that has to come out. I'll use my magnet. Spring. And that might be just about as far as we can go. There's another valve back here. It's captured in there by a little E-clip right in this location. Sometimes you can use a little pick tool and pull that out. Let me see if I can. There we go. Now, sometimes that little E-clip can be really aggravating to get out. As a matter of fact, that valve really can be left in. It doesn't hurt anything in a trans brake application. However, if you can get it out, I think it's best to do so. Now I want to remove the high-speed kick down in this location. I'll flip it upside down and I'll knock out that roll pin there. Okay, let me support it on a block of wood. Put my punch on it and knock her through. Alright, and we have a spring and a valve. May have to coax it out just a little bit. Now sometimes when you knock that pin out, you may create a little burr in there, so that's why this valve was a little bit tight pulling it out. Now there's a small screen in this location. I'll pop it out by pushing it from the other side with my small punch. All right, we'll put this aside and then start working on the other half. And the first thing we want to do is remove the pressure regulator right here. We'll take some snap ring pliers, take the snap ring out, and we can get the valves out. There we go. Now the valves that you pull out may look slightly different from this one. You have this two-piece outer sleeve. You'll have a spring with a little cup, and then you have the valve down on the bottom side. Let's see if we can get it out with a magnet. There we go. Put that aside. Now we want to remove the shift valve, which is in this bore. Once again, there's a snap ring in there, and we'll pull that out. Now there's a lot of tension on this valve. There's a big spring behind it, so I may have to kind of push down on the valve to release the tension. There we go. Take the snap ring off, and then you have this valve, and there'll be another little valve inside. May still be down in there. You have usually two springs. There we go. Then you have the other little valve. See how that is? That goes, inside that one. The one you have may look a little different from this one. The inner valve may be a lot larger. There also may be a little washer behind the springs. I don't think this one has that. And then you actually have the shift valve on the bottom. Let's fish that out with the magnet. There you go, and that's the actual shift valve. And we'll go ahead and set this aside. Now I want to take the two valve body halves and clean them up real good with brake cleaning solvent. I'll take this rifle brush, go down in the bores, make sure it's nice and clean, and then I'll start checking these two parts out for the modifications that will be needed to turn this into a trans brake valve body. Okay, welcome back. I've cleaned up the two valve body halves. I've taken my paint marker, I've marked all the areas where the cuts will be made, and of course we're doing more than just cutting, some new channels in the valve body. We'll also be tapping a couple holes to put some plugs in, and of course we'll be doing some boring where the aluminum pins will go in to block off a couple passages. Now there is one area that you really do need to have a drill press. The 3/4 inch countersinking bit that I have, we will use to cut a relief in the back of the upper valve body where the trans brake valve goes. And you know, the drill press I have is not really a very good one. It's an old one. The chuck actually wobbles a little bit, but it's good enough to do this one modification. If you don't have a drill press, you know, maybe somebody in your car club has one, or you have some drag racing buddy that has it, and you know, bring them $20 and you know, borrow that for that one cut. I think everything else can be done with the router or that small electric die grinder. All right, let's take a closer look at these valve bodies and see where the cuts will be made. Now here on the lower valve body, you see some large passageways that will be cut, and then a couple other more narrow passages. On the upper valve body, you see less places to be cut. However, each one of these passageways will be cut to a different depth. In fact, there's more to be done on the upper valve body. So therefore, I think to start the project, let's start with the lower valve body. All of these cuts will be cut to the same depth. And to get used to your router, it's best to start here on the right-hand side where these passageways are fairly wide. If your router kind of walks on you a little bit, you're less likely to make a big mistake. So we'll go ahead and bolt this up to our holding fixture. We'll use 3 of the valve body bolts in this location and here, nuts on the back side. I'll change into some work clothes because after all, when you're using a carbide bit on cast iron, you will make a lot of metal dust. And as soon as we bolt this up, I'll give you just a couple little tips about using the router, and we'll start making some cuts. Okay, you can see what I've done here. I have the lower valve body bolted to the back of the holding fixture with 3 bolts and nuts, and I have these little clamps adjusted so the fixture will drop right down in there, and of course that'll keep the tool from moving around on the bench. I've installed the 1/4 inch carbide bit, the one that has the little dome on it, and I want to adjust the base in such a way that I never cut more than a 1/16 of an inch depth at any time. So let me loosen up the base here, and I'll put the carbide tip right on the solid part of the valve body, say right here. Then I'll drop the base down, lock the router in its position, then take my fine adjustment and add another 1/16 of an inch depth. Then lock it in place. All right, now I'm ready to go. What I want to do, I want to concentrate on this cut here and here, here, and this small area here. A little tip about using a router, just a general tip. That is, you know, when you make your first cut, of course, you just cut about midway in whatever you're trying to cut. But if you're taking material off the, say, right-hand side of the bit, then it's best to move the router toward yourself, because after all, the rotation of the bit will cause the bit to be cutting into the work, just like a circular saw cuts into the wood when you're cutting lumber. If you're taking material off the left-hand side of the bit, then you want to move the router away from you. You get you know, it's a little bit easier to cut that way. Now, most of these cuts are in such a confined area, you won't be able to do that, of course, all the time. But where you can, it does help some. Okay, now let me run around to the front of the bench here. We'll start making some cuts. One thing you'll find out when you're doing this yourself, you need a lot of light. So if you can get one of those little bench mounted gooseneck type lights, that really works real well, because the router kind of puts everything in a shadow, makes it a little bit hard to see. In fact, it'll be a little bit difficult to film this, but we'll do our best. Okay, if you have a variable speed router, put it on its highest speed, put your safety glasses on, and let's start doing some cutting. All right, I'll adjust the router down another 1/16 of an inch and do some more. All right. I think we got the right depth. Let's blow it off and see what we have. Okay, it looks pretty good. You can see the floor here, you know, it's a little bit coarse, and that's because I used that dome-shaped carbide tip. If I'd used the flat-ended carbide tip, I could make that floor, you know, a little bit smoother, but that doesn't cause any problem. You'll also notice that this yellow band that I painted here, I did not make that cut. And understand, if you're not running a double dump transmission brake, there's no need to make that cut because that opens that second passageway up. Now, of course, our transmission will be modified for a double dump, so I will make that cut. And Carl tells me, you know, even if you're not running a double dump transmission, you might as well make that cut anyway because it just simply won't be utilized, you know, in a single dump setup. But then at a later date, if you make the modification to the transmission, you have already made the mod to the valve body. Okay, we still have 2 more cuts to make, and let's take a closer look at those. Okay, for this cut, I want to first make a plunge cut in this cavity right here because the hole there is actually less than 1/4 of an inch. So by putting a plunge cut there and, you know, making it the full 5/16 of an inch depth, then I have room to, you know, drop the carbide tip and then slide it over with each pass. Also, I want to bias the slot up to the high side because this area right here, I want to keep as much of that material there as possible. I don't want to cut into that a whole lot. Okay, once again, we have a slot that's less than 1/4 of an inch, you know, in diameter. So I want to make a plunge cut right in this slot right here between the 2 yellow marks. Go all the way the full 5/16 of an inch, and then as I cut this one, the same thing. I want to bias the hole a little bit to the left. I want to keep as much of that material there as possible. So as I make those cuts, I'm going to go a little bit to the left. Okay, because I'm going to make multiple cuts going in the same direction and I'm trying not to get it any wider than the 1/4 of an inch that the burr bit is, I decided to put my little fence on here. I think it'll help a lot. So let's go ahead and make this cut and then we'll make the other one. Okay, that worked out real well with the fence on there. Okay, that's the final cut on that one, but I want to blow this off and show you something. As you can see, I left plenty of material on this wall right here. That's what I wanted. But if you look right here, I came very close to cutting into this cavity. And that's because when I pulled back on the router, I came back a little bit too far. And so I don't think that's going to cause any problem, but I definitely don't want to make that mistake again. Okay, off camera, I made this last cut here for the double dump relief cavity, and I've cleaned everything up again. And now I need to make that last cut so we can put that aluminum pin in this position right here. Now what I'm going to do, I'm going to use that burr bit that has the 1/4 inch ball on the end, and I'll use it somewhat as a drill bit on my router and bore down through this cavity until I hit the floor. And once I hit the floor, I'm going to go a little further, maybe another 1/16 of an inch. And this is where I'm going to deviate slightly from the instruction sheet. I'm going to go up into the next cavity, this one right here that was opened up for the double dump, and I'm going to take that same burr bit and bore down through it to the floor and past the floor about a 1/16 of an inch. I'll explain the need for that later. Okay, I've taken the aluminum pin that came in the kit, cut it in half, made sure that it's long enough so when I hammer it all the way down into the hole, a little bit of it will stick up, and of course that'll be trimmed off later. I also added a little chamfer to the bottom. That should make it fit nicer in that countersunk area that the burr bit created. Now, normally if this was done on a milling machine, you would have a nice tight fit for the pin. Being that I use the router, I find that, you know, at the top it's a little bit loose. It does tighten up as I get toward the bottom. So I think when I hammer it in, it will have a nice mechanical connection. However, most likely it will not be liquid tight. So I'll mix up some epoxy and kind of butter up both sides of it once I hammer it in. That will reinforce it, of course, and it will also make it liquid tight. Now I want to explain why I want to add another one of these pins in this second cavity here. Okay, you might remember in the first half of the repair video, I talked about, you know, if you're adding a double dump system to your transmission, you're adding a new cavity that has to be filled up with fluid as the reverse clutch is engaged. Now that helps greatly when you release the brake, because now you have you know, a larger area for the fluid to escape. However, when you're putting fluid into it, when you push the button in, now more fluid has to go into the back end of the transmission, which could possibly cause a delay of the brake engagement. So most of the companies come up with this little item. It's called a quick set. This goes in the back of the transmission where you add that new hole, and this fills up that huge cavity in the back that would wind up having to be filled up with transmission fluid. By adding this to it, that displaces that area so it doesn't have to be filled up with fluid. Well, I believe the same problem exists with the valve body here. When I added this new cavity here for the double dump, I also opened up this long area right here. So this might be 1 or 2 cubic inches of extra area that the fluid would have to fill up. So I think by adding another pin right here and then making that liquid tight, then this area would not have to be filled up with transmission fluid either. I think it will help with the engagement. Okay, let me hammer both of these pins in place. I'll just use this brass hammer here. Make sure they're bottomed out. Now I'll clean it up real good with brake clean or some lacquer thinner, and I'll butter these pins up with some epoxy.